This is me explaining the work for FRQ2 or homework. So firstly, we have to determine if A of n converges or diverges when x equals 1. So this is what A of n equals, so basically we just plug in 1 to x. So 1 plus 3 is 4, it has 5 times 4 to the nth power over minus 6 to the nth power. And then since we know that this 4 and negative 6 are both to the nth power, we can simplify it by saying that this is actually negative 2/3, so simplified it over here. And then if you do the geometric series test, you know that the absolute value of the number of the ratio in the geometric series test is below 1, then it converges. And so as you can see, the absolute value of negative 2/3, it does in fact less than 1, so by the geometric series test this is converges. For the second one, we are told that L is a real number, or they show that there is a value of x such that L equals 15. As we showed in the previous problem, we know that A of n is in fact a geometric series. And so because you know that is a geometric series, we can use the equation of A of n, the first term, over 1 minus the ratio. So basically, we'll be using so we know that the original thing is 5 times x plus 3 over minus 6 to the nth power. I basically simplified it right here to the geometric series. And so then now we can convert over here to where it is 5 over 1 plus x plus 3 over 6. We got rid of the minus sign because that was negative 6, so that's being subtracted. So it's actually plus. So then it'd be 5 over 1 plus x plus 3 over 6, and this would equal 15, the real number. And so eventually, if you simplify it, this will become 5 over x plus 9 over 6. That will become 30. So 30 over x plus 9 equals 15. If you cross x plus 9 over there, you eventually get that x equals negative 7 because 30 divided by 2 equals 15. Then if you come back over, if you just basically plug in negative 7 once again, get 5 times negative 7 plus 3, plugging that in for the x, that will become 4 over negative 6. That basically becomes negative 4 over negative 6, which becomes 5 times 2/3, pretty similar to the last one, except this is positive now, and 2/3 is in fact less than 1, meaning it converges, so negative 7 does work out. Lastly, we have to, one more actually after this, C, where we are told that D of n equals A of n over n plus 1. So basically, we use the exact same thing from A of n, so 5 times x plus 3 to the n over minus 6. There should be parentheses around that, times n plus 1. Basically, we'll do the ratio test. And so by this, we'll be adding a plus 1 to each n. So x plus 3, n plus 1, minus 6 to the n plus 1, n plus 2. And then if we take the limit as n goes to infinity, we see that this will get crossed out, leaving this as just negative 6. The 5's will cancel out. X plus 3 to n plus 1, that will cancel with this, just leaving with x plus 3, and n plus 1 will stay the same, and n plus 2 will stay the same. So we're left with this, and then we take the limit to infinity of this, we will eventually get, by taking the limit to infinity, we'll have x plus 3 over negative 6. For that, those should be negative signs right there, x plus 3 to the negative 6, and then basically if you cross over negative 6, it will become negative 6, flip the sign, and then minus 3. That will then become negative 9 over here. Go over negative 6, it'll become positive 6. Then flip the sign, minus 3, that'll become 3. So then now we have this, but we need to find the interval of convergence of whether it can actually equal 3 or if it can equal negative 9. We just know the values between. So if we go over and we plug in firstly 3, we get 5 over 3 plus 3 to the n power over minus 6 to the n. If you you can cancel these out, which will ultimately leave you with 5 times negative 1 to the n power. This will converge by the alternating series test. I'm going to hurry up a little bit now because this is already 4 minutes. And then if you plug in a negative 9 over here, this will yield 5 over minus 6 to the n. This will eventually cancel out. This will be divergent series because 5 over n plus 1, if you have to do the limit comparison test, you'll realize that 5 over n plus 1 is basically similar to the p series, and 5 over n to the 1 power is something that diverges. So we can only have it equal 3. Lastly, if you come over to a D and you want to find f of x, which we know is twice differentiable at the secondary Taylor polynomial, We'll first find the first three terms for the second degree. So plug in 0 for n, plug in 1 for n, and plug in 2 for n, giving you this. And eventually, because we know that we always want to find f to the second derivative of -3, and we are told that they are the second degree. D of n is they share the first three terms. We know this 5 to the 108. That is actually that'll actually be f to the -3 over 2 factorial, because we just want f to the -3, not the part in the series where that is multiplied by 2 factorial. This is where I was a little confused on. I think I got the gist of it. So it'd be f to the second derivative of -3 over 2 factorial will equal 5 to the 108th. In order to find just f to the -3, we need to get rid of 2 factorial, so we will multiply it over the year, which basically just equals 2. And so we divide that, and then we eventually get 5 over 54, and that is the final answer. Alright, thank you.